Good. How do you think the answer is, Charlie?
Wait, I'll just write how I did it. Can you give me the annotation?
Yeah, sure.
X square on top, supposing.
Right.
And then they gave us a concentration, so 2 multiplied by 2 cube because coefficient is
Right.
3. And the
Good.
Kc as it is unaffected, it will still be 2. So we just get 32 is equal to x square, and then x is equal to square root 32.
Perfect. Okay. Let's get 44. It's too easy. So yeah, this one, 45. Although it's easy, but you need to do at least one question like this.
Beta?
Mm, pronounce it for me because I didn't get whether you said beta or delta.
Beta, beta.
Beta. No, that's not right thing again.
Then it should be delta.
Delta. That is right. Now, why do you think the
Uh-huh.
value of delta H would not decrease or increase but stays
I
unaffected?
think because let's say this is the uncatalyzed reaction, something like this. And let's say this is the catalyzed one. Smaller hum, but at the final, the level will be the same, right? So the change is the same in both. Maybe that's why.
Exactly. Exactly. What decreases can be the
It's the
activation
activation
energy,
energy, but
right?
not the change, enthalpy change. All right.
There is no effect on enthalpy change. So delta is correct. Okay, so moving on. Too easy. Same. Let's try this. 48.
All right. Beta.
Perfect. Okay, moving on. Easy. Yeah, 50. Try 50.
No. The Kc is 6 into 10 raised power minus 2, right?
You said 6, right?
Yeah, 6 into 10 raised to power minus 2. It's a bit
Yeah, that's correct.
blurry. All right.
Energy value, and this value shifts to the right. Because he's talking about most probable energy value, so yeah, definitely it would shift to the right. Okay, fine. Yes, beta is correct. Moving on. I
Yeah, I
guess you
was
were
doing
doing
55.
it. Okay,
Yeah.
continue.
Beta.
Good. And why do you think it's lower? By the way, it's correct, but why do you think it's lower?
Wait, I'll show you how I did it.
Sorry?
I'll annotate how I did it.
Yeah, sure. Go ahead.
So let's say this is PCL5. And this is going into PCL3 and Cl2. And they said initially there's 1 mole. So this would be 0 and this would be 0 as well. So let's say 0.025 is used up. So minus 0.25. And then for PCl3 and Cl2, there would be plus 0.25. So the final equilibrium moles would be 0.75 and 0.25. And it should be the same for chlorine. So this is initially. And then they said it is repeated with 1 mole. Phosphorus chloride heated to 600 Kelvin in a sealed flask, but the volume is different. So the moles formed would be the same. The only thing is that the volume is greater. It is now 2 dm cube. So the concentration would be the mole of PCl5. If we divide this by 2, the concentration would come out to be lower in the second experiment. But in the first experiment, it would remain 0.75 mole per dm cube because there's one dm cube only.
Okay. All right. That's a good way to do it. And I'll be honest, I wasn't expecting this from you in this way. I was thinking you will just simply think about it theoretically. You might not go for any calculations or an example calculation, let alone. So, yeah, that is right. That is a good way to do it. But remember, volume and pressure are inversely proportional to one another. And for any reaction where the increase in pressure takes it in the forward direction because of the number of moles adjustment on the left and right, for any of that reaction, bigger the volume we're going to take, lower would be the pressure, and hence the same effect as the Le Chatelier's principle, which
Oh,
means the position of equilibrium would not be as far to the right as we consider it to be with a higher pressure. So with lower pressure, that would be less, and more the position of equilibrium is going to move towards the left side, the lower would be the value of equilibrium concentration of PCl5 at equilibrium. All right. I hope you get the point. Do you?
yeah, yeah,
Good.
yes.
So you can seriously do it theoretically. You don't have to take an example calculation. But if you'd like to do that just to be on the safe side and just to have a clearer picture, you can always do that because you never took too much time for your example. That's fine by me. If you took too much time for that example, I would have definitely not have recommended it. So, um, just a second. Yeah, go ahead with 56.
Charlie,
Your voice was lagging.
Charlie.
Charlie. And why do you think that is correct?
In the first reaction, H2SO4 has lost the hydrogen. Same goes for the second, HCN, and same goes for delta, leaving the only option Charlie.
So what exactly happens in Charlie?
Um, it's converted into H2O and CO2, and HNO2 has donated the proton, so it's the acid, and HCO3 minus would be the base.
Very good. HNO2 actually donated a proton to HCO3 negative, which made it H2CO3. H2CO3 is carbonic acid. Carbonic acid is unstable at higher temperatures and can easily decompose to give water and carbon dioxide. What are we left with over here? Of course, that is simply NO2 negative.
And 2 minus, yeah.
So yeah, it donated a proton all the way to these uh, HCO3 negative ions. But the way you were doing it is also good.
No,
Moving on, what do we have next? Yeah, go for it.
50. Beta.
So how do you think that is beta?
The expression would be something like this for Kc x over, basically it would be x over 7.6 into 10 raised to power minus 6 raised to power 4, and that is being multiplied with x here. So x will get cancelled out with x, and we'll have 1 over 7.6 into 10 raised to power minus 6 raised to power 4. So that gives beta.
Doesn't seem right.
The answer or the explanation?
Both actually.
Mm-hmm.
So for the value of Kc,
X, suppose that is x, and it should be right. Let me see. 7.6 into 10 raised to power minus 6 raised to power 4. Oh, it's coming out to be alpha actually. I don't know what I did wrong previously. 3 into 10 raised to power 20.
3 10 raised to the power 20. It's a pretty big answer.
Yeah.
And since we have oxygen in the denominator, oxygen is a negative number, and it's raised to its power 4. So that makes a lot of sense.
Yeah.
And the good thing when I look at this is that just the last two answers are negative. If you think about the basic math and what you just told
Yeah.
me,
Yeah.
the answer is supposed to be a very big number, which
Very big
only
number,
is
exactly.
close
Is
to
alpha.
A.
Yeah.
Okay, so clearing it up. Let's see, 58. There you go.
All right. Beta.
Beta. How?
Initially there would be more reactant molecules, so the chances of successful collision should be greater. So the rate of formation of methanol, um, methanol, it should be higher as well. And then as the reactants molecules are being used up, I think less collisions would occur, so the rate must decrease eventually with time for the formation of methanol.
But don't you think beta is abrupt for your explanation?
I mean, the rate is increasing initially, and then it decreases and it's becoming less.
No, it never decreases. Actually, the rate increases, but the slope becomes more steep in the center. And yeah, towards the end, it becomes less and less. I mean, the increase.
Hmm.
Okay. I would rather say that A is the answer.
E. Yeah, okay. Rate is higher than it's becoming. Yeah, yeah. Okay. A makes sense.
Can you tell me why C is not the answer?
C, it's constant, the rate, I mean, initially. And that doesn't seem right.
Right. Good. The point that you can always discuss with C is the sudden change. While here, the
Yeah.
change, the
So,
increase or the decrease is
yeah.
gradual. It's not sudden. And gradual is what we usually get, not sudden in these cases. Okay. Let's see. Uh, no, 59 is too easy. 60 is even easier than that 59. Let's see. Yeah, what about 61? Some of it is not from this chapter, but hope, I still hope you'll be able to do this correctly.
All right. Beta.
Beta. And why do you think first beta is correct? Why do you think alpha is not correct?
Alpha is, the statement is correct because there are less moles of sulfur trioxide on the right hand side. So increasing the pressure would shift the equilibrium to the right.
Okay, so why is this still incorrect? Must be a reason behind it.
Yeah, beta is incorrect, the statement, because the forward reaction is exothermic. So increasing the temperature would shift the equilibrium to the left, and there will be a less yield of sulfur trioxide.
Okay, good. Yeah, this one's good. 62. Go for it.
Charlie,
Good. How do you come up with Charlie?
um, okay, so the expression would be like this: hi square, and then let's suppose the volume is 1 dm cube to make calculations easier. So this would be 2 times 0.3,
Right.
and Kc would still be 60 because the temperature is unchanged. So hi square, the value comes out to be 36, and squaring node gives us 6.
Good. We're done with the question like 63, so let's skip it. So are we with 64, 65? Let's go with 65.
Charlie?
Good. Okay. 67.
Delta?
Right. Easy. 68.
Um, Delta?
Why not Charlie?
The power reaction is exothermic, so increasing the temperature should decrease the concentration of ammonia at equilibrium.
Good. Good. Okay. So we're done with 69, 70, 71's easy. 72, we're done with question, I guess, one. So 73 is similar. 74. This should be easy because Boltzmann distribution curve was pretty simple.
So we can use the same thing here.
Yes, we can. We can, and we are
So
supposed
then
to do
that
that.
should be Charlie. The peak is higher and then gets lower for
Which
the
peak is
dotted line.
higher in Charlie?
The dotted line one.
Right. So lower the temperature, higher would be the peak in Boltzmann distribution graph. Higher temperature, the peak gets lower and lower until there comes a point where it is flattened out. We usually draw one step lower peak with 10 degrees centigrade rise in temperature. Also that in this case, both the peaks are points are supposed to start from the same point, same start, but the one that is at the high temperature is supposed to end after with a bigger tail, you can say.
All
So if
right.
you look for those points, Boltzmann distribution graph should not be a problem. 75 is easy. So it's 76, 77, 78. Let's go with 78.
beta.
And my only question is, how did you come up with the denominator 3 and not 4?
The denominator.
Yeah, denominator.
The expression which I made was x square on the numerator, and in the denominator 1 minus x whole square, and this is equal to 4. And then I solved it for x.
Okay, good, good.